Hi, we're here to talk about automating builds as part of our DevOps enterprise. And I'm feeling a little giddy and goofy right now because it took 45 minutes to make my Linux laptop mirror its display to the big monitor. And this is now our fourth start after various technical difficulties with our camera. So I'm set to throw the machines out the window. We're 10 stories up and they were smashed to bits down on the ground. Luckily for them, the windows don't open up here or they'd be goners. We automate builds as part of DevOps because everything we do should be done with a mind to delivering value to our customers more rapidly. We do this, first of all, because then the customers have valuable things more rapidly. But secondly, we want to do this because it accelerates our own learning, or as the DevOps people like to say, we gets us more learnings, something like that, I don't know. Because we're putting out our software often, we can get feedback often, learn, correct our software. Very good. And automating builds is part of that process. We should always keep the end goal in mind. We don't want to adopt technology because, well, it's the latest technology, everyone's using it, or because it's cool, because we don't want to do resume-driven development where we adopt the technology because, well, I can get a new job if I bring this tool in at this company here. We adopt the technology in the service of our customers. Why do we want to automate our builds? We want to automate our builds for several reasons. First of all, if we don't automate them, it's boring. Doing a build by hand is a tedious, error-prone process. We forget a flag for the compiler, link to the wrong library. You've done that often, haven't you? Right? She's had the same error many times. Building by hand is tedious. We want to give the machines the boring jobs, and the humans do the interesting jobs. Maybe that's why the machines haven't been cooperating with me today, because they heard I wasn't planning on giving them the boring jobs. They may be a little, well, maybe I should turn off the mic here before we go on so it doesn't hear what my plans for it are, huh? Well, in any case, it's boring. Because it's boring, it's error prone. When a job bores us, our minds shut off and we make mistakes. And we forget to push an important component into production, so the authentication server fails, or we forget to run our security checks. We tend to miss steps. Even if we build the product correctly, we'll miss steps. So when we automate a build, we can do things like put into the build process automated testing, automated security checks. When we build by hand, we may be in a hurry. We know we didn't really impact the security aspects of the app, so we don't bother checking, and all of a sudden, all 150,000 of our customers' credit cards are circulating around the globe and being used to buy bitcoins and things like that, or whatever. The last reason I want to point out is that if we build by hand, typically what people do is they write a document. Here are the steps you take to build this item. The problem there is that the documents get out of date. People update the build process. They're programmers. They prefer programming to writing documents. They forget to go update the document, and the document's out of date. When you script the build process to automate it, it can't get out of date because it is the build process. So the script that you use to automate the build process itself serves as documentation for the build process. All right, let's erase this stuff. and talk about what build tool we're going to use. So, you're not going to stop me again, are you? Because I'm good. All right, so great, that's good. No more pauses. We're going to use Make. Why use Make? Make is widely available on all Unix-based computers and is can easily be acquired for a Windows system as well. It's free. It's been around a long time, so it's a little old-fashioned. Maybe we should use a newer tool like Ant or Maven, and those things are fine, but because it's been around a long time, there's lots of documentation, lots of knowledge on how to use it, and for our purposes, it's perfectly adequate. We're introducing people who have not encountered automated builds before to the idea of automating builds. So it doesn't particularly matter if there's a fancier tool that has a few more features. We can learn all the fundamentals of automating builds perfectly fine with Make. And a little secret, the professor's been using Make for a long time, so it's kind of easy for him to teach this one. So, what does Make do? Make is actually a little language. And this is a design pattern that's good to be aware of. Many times when you have a task you need to do again and again that's rather specialized, a useful way to automate whatever parts of it you can is to write a small language that is tailored to that domain. So Make is a programming language, but it's a mini language. You're not going to want to write a calculator or a web server in Make. You couldn't do it. It's a little language tailored to building software from its components. And because it's tailored to that, it's very easy to express certain ideas in it. What it does is it executes what's called a makefile, and a makefile is instructions on how to build software. What we have in a makefile what the targets are made from. All right, so the bulk of the makefile, dependencies. Sorry, we've got one more item. Let's get rid of this stuff. And the third component is instructions. How to build targets from dependencies. So we've got a target, something we want to build, our calculator. We have, what does the calculator depend on? Well, it depends on these 3 C++ files, these 4 header files, this library, for instance. There
There may be some text files, some language files, so we can display messages in different languages, various components that someone else come in? Various components that the software is built from. So the target is the calculator, the dependencies are the components that build the calculator. Instructions, well, what do we have to do to build this? So what we're going to do to understand this better, there's one more thing we want to mention in general. In a makefile we find this kind of structure. So I'm going to show you how these occur in the makefile. And how come Fulton Sheen got someone to erase his chalkboard for him, huh? Why don't I have someone who runs out and erases the board for me while I'm talking? That's what I need next. We've got target, dependency 1, dependency 2, and then as many dependencies as we need. Instruction 1, instruction 2, etc. So we have a target, what it depends on, and how to build the target out of the dependencies. Because Make was developed in 1973, computers were a lot slower. Hear that? You're nice and advanced compared to the earlier computers. Okay, good fella? All right. Gotta keep them on my side. So, because computers were much slower, you're building a large C program. Your build could take hours. So what you wanted to do was you wanted to minimize the amount of things you had to do on any particular build. So, given the importance of this, Make works on dates. And in particular, when you ask to build a target, it checks the dates where these dependencies were last updated against the date of the target. And if any of the dependencies are newer than the target, it will rebuild the target. If the target is newer, Make decides, oh, we don't need to do anything. The target doesn't need to be rebuilt. It's up to date. This is something people who are new to Make can often be puzzled by. If for some reason you need to make this target, you know it's out of date, but the dates on the disk don't reflect that. You'll try to make the target and nothing will happen. People get very puzzled by that. What you need to do, Unix has a command called touch, and you can run touch and just touch any one of the dependencies. That puts a new date timestamp on it, and then run Make again, and that will force the build. All right, let's look at an actual Makefile, and let's see. I don't know if we can make this thing reach. We're a little shy of where we want to be on this, but that's all right. I'll run back and forth. Maybe I could ask my trusty assistant, maybe to scroll. So we're okay where we are, we're where we want to be in the file right now. But now let's go over here to the projector that we finally got working after long struggles. So how does the size of the font look here? It's okay. It's a little small. Why don't you, can you hit Control plus? Okay. A little bigger. Let's not make it too big because we want to get a decent amount on the screen. That's better? All right, excellent. This is a rather hefty Makefile. So there's examples of lots of things we'd like to do with Make in this file. In particular, you're going to see in this file how we don't just build the main program. Anything associated with the project that gets built goes in the Makefile. What we start out with is we set up a bunch of variables. Make, it's not a full-featured programming language, but it does include variables. And we want to do this so we don't repeat ourselves, right? We don't have this name scattered all through the Makefile. We define it once, and then if these are some directories we're going to use. If we move the directory, we just change the variable. We don't need to go and change it in 20 places in the Makefile. All right, if you can scroll down a little bit, I think just hitting down arrow should do it. Okay, so scroll until this is up at the top of the screen. Okay, great. That's good enough. Make does allow us to shell out and run other Unix commands, and that can be very useful. What we're doing here is we're getting a list of HTML files that we want to build, because in this system we're occasionally building our HTML files from other components, like things that we want to include into the file. And we also do error checking on the HTML files. What we're doing is we're shelling out and we're running the Unix ls command here to get a list of our assembler files on the file that holds our assembly language samples. Here we actually are running a long pipeline. We're LSing for our PTML files, and then we're using the Unix stream editor, sed, to substitute HTML for PTML and put in, to strip out the directory HTML source. So this shows that what we can do in a Makefile is not limited to what we can do in the Make language itself. We can go out to the shell and run other Unix commands and assemble bits of information we need. Here we begin to see our targets and our dependencies. Make allows an empty dependency. That means if you type make util, anytime you do that, it will build this, because there's no dependency that we can check to see if the target is up to date. Let's just go over to the whiteboard for a second again. So this is what we're going to do when we want to build the target. We have a default file name of Makefile, and we're going to pick a target out of that Makefile, and in this case we would run make util at the command prompt. So make util says look in the current directory for a file named Makefile. In that file, look for a target named util and do whatever the instructions are to build that target. All right, let's go back to the screen over here. So when we have a utilities submodule, we update that by pulling our submodules. We probably should change the name of that target, because this is going to rebuild all the submodules. We have a navigation bar that appears on the left side of the website. That's built from components. We actually fill in a comma-separated file in a spreadsheet and build our whole menu from that. This says that this depends on the utilities because it's going to use them. So whenever we make the nav bar, we want to make sure our utilities are up to date, and that we're then going to run this program and take this as its input and this as its output, and then we're going to use Python and run this other Python program. These are sample programs that the navigation bar links to. All right, let's scroll down again in this and get this up to the top. So line 37, excellent, that's good enough. Yeah, when I say up to the top, we need to come down one line. When I say up to the top, close enough, right? Close to the top. So here's a rule for making HTML files from PTML files. PTML is a made up extension pre-HTML. We needed something to have a different extension so that we could make a rule for make. Make knows that often there are situations where whenever we have a .o file, we build it from a .c file with the same name. So it knows how to build, or gives us the capability of building these targets based on extensions, on a rule dealing with the extensions. So this says, here we're going to build any file name .html is built from a PTML file and a number of things that we're going to include in the file. For instance, the navigation bar, a quiz, a common header, things like that. So, because this target is being built for GitHub Pages, which only serves static pages, so we need to do includes in advance. We also have a Django server that will do the includes for us, but this target in particular is for the static web server. So when we're going to do this, so if we had main or index.html, we're going to build it from index.ptml. We're going to run an HTML checker on it. This is an example of doing automated tests on targets as we're building them. Then we're going to pull in the includes. Then we're going to do a git add on the file because perhaps it hasn't been built before. If it was built before, git adding, it's not going to hurt anything. If it wasn't built before, git add means we're not going to forget to do that. We can run make local as a target, and that will build all HTML files. And this is a step when you've updated the HTML pages and you want to locally look at your work, you run make local. We can build, we've got sample assembly programs, and we can build PTML files from them using another little utility that takes the assembly file and formats it nicely for display on a web page. So let's scroll until line 50 is near the top. So again, we don't need to get it exactly at the top. Good enough, good enough. Okay. Build the static website describing the project. Well, if we want the static website, we need to, it depends on the includes and the HTML file, so these targets can be nested. So this target of building the website depends on an earlier target of building the HTML files, and those are built from the PTML files. We also have help, and that itself, our help pages are a buildable target as well. We commit everything. The dash here means don't fail the build if this command exits with an error. By default, when we're doing these steps, anytime one of these commands fails, make will stop the build and report the error. Here, the person building the website might have already done the commit by hand. So in that case, we don't want to stop the build. So make allows us to prefix a command with a minus, in which case that says ignore any errors produced by this command. So we're going to commit and do a pull, make sure we're up to date before we push. People test locally for this project in a Docker container. That container itself is a buildable target. An important thing, this makefile is rather large, but it's important that not only have we automated our builds, we haven't automated them in 20 different shell scripts. By using a build tool, what we can do is collect all our build automation in one spot. So whenever someone has a question, how do I build help? How did I get this Docker container? What if I lose it? Well, how do I get it again? How do I build the static website? How do I build the dynamic website? The answer is always in the makefile. Anything we build, we we make it a target in the makefile, then put in the instructions. Here are the steps to build this thing. So this is building our Docker container, built out of a Docker file that shows what the container must include, what it must contain. Let's scroll down to line 64, 65 is near the top. So, yeah, great. So this is actually building our help files. This is a lot of stuff going on. We have we're following the principle of don't repeat yourself. Everything should have a single source in the system. And so what we do is we document our various assembly language commands in the Python files. So this is an assembly language emulator, by the way, written in Python. And we document those commands in the Python file where we're writing them. And that way we have a single source. They're likely to stay up to date because the person reprogramming the command sees the documentation right there, right next to the program. So what we do then to build our help files, we yank that documentation out of the Python file and construct through this rather elaborate process our help files. And we're actually creating help files for both web servers in these steps. So whenever we know that these sources, and these are the sources, these various Python files, we should find a way to turn this into a single command. Luckily we don't have so many of these, but I don't like the fact that this is 5 different lines. But we proceed a step at a time. We advance in automation as we can, how we can. Once again, even the steps to push our work into our repository are included as part of the build, so we can't forget, right? One of the things we mentioned, why automate our builds? If we don't automate them, we're going to forget key steps. One kind of thing that can happen all too easily is someone rebuilds the help files but forgets to push the files into the repository. These are a built product. So why do we have them in the repository, you might ask, right? I could tell my trusty assistant was about to pop forward. Why would you put a built product in the repository? In this case, we're serving the pages from GitHub Pages. These pages we're building, we can't serve them from GitHub Pages unless they're up on GitHub. So typically you don't put built products into your source code repository because you can build them. You put sources in there, not the built products. But we have occasions like this where we actually want to serve the help pages from GitHub Pages. And if they're not on GitHub Pages, they can't be served from GitHub Pages. Let's scroll down again. I think we're about done looking at this. Okay, now there's actually a couple other interesting things in here. This is building JavaScript helper files. Don't know why we need to, function, I don't know why we need to add this every time, but I'll investigate that. Other people than me are programming this makefile, so I don't know every detail of everything that goes on in it. We have one of my colleagues here, whose name happens to be Haldoon, you might guess, needs a zip file of the project. He doesn't like GitHub, so it's like, okay, well, we won't make you go to GitHub. We'll build you a copy of everything in this. So we have a target to build the zip file for Haldoon. Scroll up a little bit, and I think this is the last thing. Oh, no, go a little further. Okay, that's great. Perfect. And then we're at the bottom, so we have to be done. For Django, the database is a buildable product. The database schema is changed by changing a file called models.py. And when that file changes, we need to rebuild the database. We probably should have a dependency here on models.py. What do you think? Probably, yeah.
So we'll have to talk to Cindy about that, see why she's got no dependency here. Maybe she's right. She's very, very sharp, so I'm not going to say for sure she's wrong, but it looks to me like maybe we want a dependency there. But this says to rebuild the DB, you do these this is a Django utility. And we rebuild a bunch of Python files that are instructions on how to recreate the database. And of course, we put those Python files into the source code repository as well, so that the instructions on building the database are under source code control also. And here we have our last two targets we're going to look at, because after all, they're the last two targets, so I can't really scroll down any further. I better stop at this point. We have a development and a production server, and we can build both of those from the Makefile. And we run a large suite of tests. We actually have, I don't know, 1,200, 1,500 automated tests we run on the product. Then we commit it, push, and then we log in to the server where development lives or production lives and pull the repository. This is a kind of step could be done with something like Jenkins, but the way we're doing it here works just fine. We pull the new source code and then reboot the Django server. This is automating this was a great step forward, because repeatedly we would find ourselves trying to put a change out into development or into production, and we go, oh my, the change didn't work, what happened? And we realize that, for instance, we had forgotten to reboot the server. So we're wondering, why didn't our change work? Oh, did you reboot? Oh no, I forgot to reboot. Or we remembered to reboot, but we had forgotten to pull in the new source code. This is a great example of the kind of thing. It's tedious. You have to do it again and again. You wind up forgetting a step and frustrating yourself and kicking yourself because, oh, I forgot this yet again. I forgot again to reboot the server. Don't kick yourself for forgetting it. Automate it. Automate it, huh? That's the DevOps way, okay? Automate everything. All right, good night.